Hi everyone, how are you? I'm okay, but a little bit bored. I miss the normal life we used to have. Having dinner with friends, walking park, playing soccer, visiting the city, and many other activities. I've never seen a crisis like this. I want to know how long this situation will sustain and it to be ended soon. Today, we are going to cover chapter 6, which is about data management. Data scientists, data analytics, big data, and many kind of stuffs are related to today's topic. I believe many of you guys are interested in data analytics and becoming a data scientist or working in this field. Although this lecture is mainly conceptual as usual, the knowledge you will learn from this chapter will help you in the future when you learn a real hands-on skill on data analytics and data management. We have two learning objectives for this chapter. The first one is define terms in the data analytics and describe how data analytics affect business and decision making. And second one is explain core concepts of database management and data warehouse. Okay, let's get started. I think you guys must heard about terminologies of business analytics or data analytics, right? But have you heard about decision support systems or business intelligence? Decision support system, shortened to DSS, refers to interactive computer-based systems in which decision makers utilize data and models to solve unstructured problems. This terminology was used in the 1960s. Later, people started using other terminology, which is business intelligence. It is umbrella term that combines architecture, tools, database, analytical tools, application, and methodology. And nowadays, we are using new terminology, business analytics, data analytics, or just analytics. The important thing here is what is the difference between business intelligence and analytics. Both terms provide insight into the business operation and future decisions, but it comes down to the differences in how they do it and what information exactly do they provide. Business intelligence refers to tool and technology for analyzing and visualizing past data. Still, at that time, before the mid 2000s, we did not have the ability to collect, store, and process data in real time. So BI, business intelligence, mainly focuses on the pattern and trend using past data without digging too much into the whys or predicting the future. And since the mid 2000s, we have been using terminology analytics instead of BI. Contrary to BI, advanced analytics refers to tool and technique used to understand why something happened, not only why something happened, but also predict future outcomes or discover hidden patterns in large data set. With the data capability, big data capability, business analytics also uses these whys to make prediction of what will happen in the future. And now we are talking about the generations of business intelligence and analytics. At the early stage of business intelligence, we can say the first generation of BI BI focuses on structured quantitative data largely from relational data. From the second generation of BI and business analytics enables us to include unstructured data from the web, such as web interaction log, customer reviews from websites such as Amazon, eBay, or social media such as Facebook and Twitter. And nowadays, at the BI and BA 3.0, third generation, we can utilize data from mobile devices and Internet of Things. And the next is types of analytics. I think it is the core knowledge of this chapter. So you should be able to articulate the differences between descriptive analytics, predictive, and prescriptive analytics. So I want you to look at this explanation for each type of analytics carefully. The first one is descriptive analytics. It focuses on describing the past status of domain of interest using a variety of tools through techniques such as reporting, data visualization, dashboards. Do you remember we learned how to draw the data charts using the data stored in the Excel file, right? It is one example of data visualization and descriptive analytics. And the next one is predictive analytics. In contrast to the descriptive analytics, predictive analytics not only describes what happened in the past, but also predicts what might happen in the future. Can you see the difference? And the last one is prescriptive analytics. It is the most advanced analytics capability, so not many organizations use it, but you have to know what it is. Uses results of predictive analytics along with optimization and simulation tools to recommend action that will lead to the desired outcome. And you can see it is the normal process of analytics. So firstly, you have to know what is your analytical questions or business problems. You may want to know whether and how new marketing promotion affects the sales performance of your firms in the future, right? Or whether and how new entrant toward the market affect your firm performance, right? And then you have to know what kind of data you need to answer these questions. Might be firm's financial data or customer reviews or industry level financial data and so on, right? After identifying the data sources, you have to select and collect data. You can simply download the data from the Bloomberg database or Wharton CompStat. Or you can use some data mining techniques to crawl data from website or can survey people. But the data you to collect will have a lot of noises. It means it must have missing variables. It is not standardizing. So you have to clean, or we say cleanse data and transform to be standardized. From start to here, we can say the processing stage. The processing stage accounts for around 70% of the whole analytical process model. So in reality, many high-tech firms in San Francisco or New York outsource this job to other firms in Asia, such as India or China. Once you have clean data and transform data set, you can start analyzing the data to answer your questions or based on your purpose. And then you can interpret the result and find some implications and suggest some better solution for your organization. So I think this step is very important for you, right? And we cannot disagree that regardless of industry, analytics are actively used to improve firms' performance, right? I know it is a hard time now, but many people lost their jobs and more will lose it soon, right? But I believe finally we overcome it as we always did. Anyway, what I want to say is we could see many job openings for data scientists or people who are good at data and analytics. Absolutely, marketing area, you can see you can see Amazon's recommendation system and retention modeling. Many grocery companies use market basket analysis and with techniques, we can identify different customer segmentation and use different approach. And in the financial or insurance industry, we can use analytics for risk management, such as fraud detection and credit risk modeling, right? Um, and the logistic industry uses data analytics for demand forecasting and supply chain analytics. Not only private firms, but also government and governmental agencies use analytics to detect tax avoidance, money laundering, and terrorism detection. If we are in the classroom, I would ask you other examples and ask you to share it with other friends, right? I miss it. Better analytics capability helps us to respond to threat and opportunity in the market faster and better. External factors in the business environment, such as changes in customer demand, competitive pressure, and changing regulation, can create both threats and opportunity to which businesses need to respond. The more rapidly businesses can recognize changes and move to account for them, the more competitive they will be in today's ever-changing business environment. Data-driven decisions enable businesses to respond faster and better. Okay, let's talk about descriptive analytics. So it is the most basic type of analytics, right? With descriptive analytics, we ask what happened already. There are some techniques in descriptive analytics you have to know. Okay, first, you absolutely should know about data visualization. It is a popular technique nowadays. Now, data visualization is a representation of data in graphical and multimedia formats for human analysis. We can say a picture tells 1,000 words. It means rather than looking at raw data in the table, using chart will be more helpful in understanding some patterns or trend on the data. For your understanding, I prepare some cases. Let's click these links and look at it together. So one guy, data scientist, shared his project looking into the coronavirus cases. Here you can see some code, right? Code, it seems he used R programming, right? He loaded the raw files with CSV format, and then we can see the file stored in the table, right? The figure only can show a part of the whole data set, but originally it seems there are around 14,000 rows in the data set, right? And given the current situation, we might have some questions like which ages have a higher chance of dying, which ages have a higher chance of being discharged from the hospital or recovering, which ages get the coronavirus, right? To get answer to these questions, we can draw plot, right? Rather than looking at data in the table, this plot is very telling uh, of the impact of coronavirus on different age ranges. So you can see here, right? It is a data visualization. You remember that we draw charts using the data in the Excel assignment, right? Without showing precise values, graph and chart can depict relationship in the data, right? You can look at here the distribution for death peaks at an older age, around 75 years old age, whereas the peak for those who recovered was at about 45 years of age. And the peak for those discharged from the hospital peaking at 30 years of age, right? You can look at other part on this article. Can see China absolutely has the most highest number of in terms of death toll or confirmed cases, and South Korea's following. But it seems it's outdated data now. Italy or Spain, Germany or USA have more serious situation now, right? And here are source, right? Now confirmed cases and death toll in Europe, right, has been rising, and it has already surpassed the death toll in China. But personally, I cannot trust the data from China. Luckily, Korea's situation seems fine now, although we cannot check it from this data. Okay, go back to the lecture slide. So information can be visualized through digital dashboard, which are similar to your car dashboard. Only in this case, they display the key performance indicator necessary to understand how the company is operating, right? And do you remember that when do we use a pie chart, right? Like a pie chart. What are the advantages of using a pie chart over other types of charts? The pie chart is useful to display the relative proportions of multiple classes of data, right? So from the figure in the left part, we can see which sub-majors in the business schools are the most popular and at the least, right? And from the figure on right, we can see the trend of the enrollment of the students and its projection, right? So, okay, we stop here today and we will continue covering chapter 6 in the next lecture. Stay healthy and have a good day. Bye.